Power is defined as the rate at which work is done or energy is converted from one form to the other. In our previous videos or classes, we learned that energy can be converted from one form to another. And we also learned that, for example, a battery can convert chemical energy into what? Electrical energy. All right. So the rate at which this conversion takes place is called power. And the formulas for power is, we have power is equal to the work done, all right, the work done over time taken. Also, power can be equal to the energy over what? The time taken. So these are two formulas we can use to solve for power. And please note that what we are doing here is mechanical power. All right. So it is the rate at which work is done or energy is converted from one form to the other. Now I will show us a next formula for power. I will show us a next equation that we can use to solve power. And this equation connects power to speed. Now, from this equation, we are told that power is equal to the work done over the time taken. And also, we were told that work is equal to force times distance. That means I can take off my work done and replace with what? Force times distance. So therefore I can say that power is equal to force times distance over time. Good. Now, if you recall again, distance over time is the same as my speed, v. So therefore, we can say that power is equal to the force, which is F, times distance over time, which is my speed, v. So here is a next formula we can use to solve for power. And please note that the unit for power is in joules per second. Now, how did I get that? If you look at this definition, power is energy over time. And this is energy in joules, time in seconds. All right? So from this formula or equation, we can see that the unit for power is joules per second. Okay? Also, we have a next equation for power, which is in watts. So these are the units for power. It can either be in joules per second or it can be in watts. And please note that we also have larger values for power, but it can be in kilowatts or it can be in what? Megawatts. All right. So this is the formulas and the units for power. Now, in our previous classes, we said that efficiency is the ratio of the power output to the power input. And please note that efficiency has no units because it is a ratio of the same quantity. So efficiency has no units, but it is expressed in percentage. So I can write it as this is the ratio of power output to the power input. All right. Now, please note that efficiency has no units because it is a ratio of the same quantity. It is expressed in percentage. All right? It is expressed in percentage. I can write a formula for this. So I can say therefore that efficiency is equal to our power output over power input. So therefore, efficiency for power is equal to P subscript O over P subscript Rn. So here is an equation we can use to solve for efficiency as it relates to power. Now, from this question, I'm giving the work. My work is given as 25 kilojoules. If you don't mind, you can convert it to joules. It becomes 25 times 1,000. That gives us 25,000 joules. Also, we are given the distance of 50 meters. My distance is 50 meters. We are given a time of 40 seconds. So, to get the value of the force, which is A, I can use the formula, which is work equal to the force times my distance. Okay. What next is to put in the values. My work is 25,000 joules. So my work is 25,000 joules. Is equal to the force is unknown times distance is 50 meters. So to get my force, I have to divide both sides by 50. So I will divide by 50. I will divide by 50. So 50 cancel 50. So therefore my F or my force is equal to 25,000 divided by 50 will give me 50 newtons. Now, if you use 25 kilojoules, your answer should be what? Should be 0.5 kilonewton. So that is our answer for the force. So the answer is what? 500 Newton or 0.5 kilonewton. If you had used 25 kilojoules, your answer should be 0.5 kilonewtons. So that is correct. We are asked to find the power. Now power, P, is equal to the work done over my time. Now the power is giving us 25,000. My time is giving us 40. So therefore, my power, 25,000 divided by 40 will give us 625 joules per second. 625 joules per second, or I can say 625 watts. That is our final answer. It says a lorry is traveling with what? A speed of 42. So my speed is what? 42 kilometers per hour. The first thing I do here is to convert this speed to meters per second. So therefore I can say 42 times 1,000 divided by 3,600. That will give us 11.7 meters per second. So one decimal place, 11.7 meters per second. Now, the force is giving us 750 Newton. So my F is giving us 750 Newton. And we are asked to calculate the tractive power. So therefore I can say that my power is equal to the force times the speed. My force is 750 times my speed is 11.7. So when I put this in my calculator, I should get 8775 watts. 8775 watts or joules per second. So this is my final answer.